Welcome back. Let's take a look at question 5 of the STAR test of 2019. Question 5. Which graph represents y as a function of x? So this question is asking for a function. So let's think about what prior knowledge do we know about function. So we have learned that function is a special type of relationship between x and y. It's a relationship between x and y, and it is special because for each x, we also say x can be the input. For each x or each input, there's one and only one y, or the output. We say x is input, y is output. So for each input, there's just one output. So that's the special type of relationship that we need to look for. And note that we are comparing the graphs. So for graphs, we have learned a quick and easy method to test if there's a function or not. That's called the vertical line test. Vertical line test. So if we want to do vertical line test, we will draw a vertical line on the graph. And we can move this graph. We can move this graph to different parts of the function. See, with a vertical line, say when this line is here, so every point on this line, the x value is 2. The x value is 2. And if this vertical line has one intersection with the function we are looking at, if it has one intersection, say it has one intersection here, that this intersection has the x value of 2 and it has a 1 y value. So with each intersection, there's a x value and there's a y value. Because all the points on this vertical line has the same x value. So the intersection should be just one intersection. One intersection means for the same x value, there's just one y. So that meets our criteria. For the same x, there should be just one y. So for this same x, as on this vertical line, there should always be just one intersection or just one y. So that's how vertical line test works. And that's what we know from the past, from what we learned in class. Now that we have 4 graphs, to solve the problem and find out the answer, we just need to use a vertical line test on each graph to see if it passed the test. So we have done this vertical line test on graph 1, and it seems like it's passing the test. Like wherever I move this vertical line, there's always just one intersection. There's always just one intersection. Next, let's try graph B. So graph B, if I draw a vertical line here, you will see, hey, there are two intersections. There are 2 intersections. That means for the same x, this graph has 2 different y values, So that doesn't meet our criteria. For the same x, there should just be one and only one y. But on this graph, it has 2 y. One is positive, one is negative. So this one is not a function. Let's try the third one. So if I draw a vertical line here, I will see, hey, for some parts of the function, there are 2 intersections. See? There are 2 intersections. That means for the same x, it has 2 different y's. That doesn't meet our criteria. So this is not a function. Well, on certain parts of the graph, say here, there's just one intersection. but we know to be a function, you have to meet the criteria in any parts of the graph. So if you see in certain parts there are two different intersections, then this graph cannot be a function. Now let's try it on the last function. Last function, it is a vertical line itself. So if we draw a vertical line, and we can see, hey, these two, they are overlapped. They are overlapped. So in this case, is it a vertical line? Is it a function or not? As we said, when two lines overlap, they have numerous intersections. Every point is an intersection. So this vertical test will give us numerous intersections. That means for the same x, it has numerous values of y, and that does not meet our criteria. So this one does not pass the test. Now it seems like A is the correct answer. It is A. Did you get the correct answer?